All right, I'm back. We're going to talk about the difference quotient here. Now, the only reason we're covering this is for the fact that you're going to need it for calculus. But it is good practice working with a more abstract idea of function notation. And so I want you to know that the difference quotient, it looks scary, okay? It looks different, but it's just slope, okay? It's just the equation for average rate of change. It's a change in y over change in x. So let me show you where this formula comes from. If we think about a graph, we have a graph, okay? And let's call this x. So normally we'd have like our x1 and we'd have some x2, right? So we have our x1, we have our x2, and if we wanted to find the average rate of change between these 2 points, which is the slope of this line, we would do the change in the y value. So let's call this f of x1. Let's call this f of x2. Okay? So the slope, the average rate of change between these 2 points would be f of x2 minus f of x1 over x2 minus x1. So we're just going to reframe this a little bit differently. So instead of calling this x1, we're just going to call it x. And instead of calling this x2, we're going to say that the distance between these 2 points is called h. And so this is x plus some distance h, which then makes f of x1 equal to just f of x, and it makes f of x2 equal to f of x plus h. And so if I plug these into this formula again, this becomes f of x plus h minus f of x, and then x2 is x plus h minus x, and so the x's cancel, and I'm left with this equation, okay, or expression, sorry. So what does this all mean? Well, basically what it does is it gives us a function, it gives us an expression for all of the average rates of change that you could possibly have between any 2 points on the graph of a function. So let's go ahead and implement this, okay? This is going to be a more complicated problem. You're going to need a lot of space. So if you're starting a new page in your notes, or if you're doing this along with me, just realize that we're probably going to get pretty low on this page and fill up a lot of space. So let me write down the difference quotient again. We have f of x plus h minus f of x all over h. So if I want to find the average rate of change for between any 2 points on this graph of f, I need to make this expression up here happen. So we start with f of x plus h. F of x plus h is going to be 3 times x plus h squared minus 2 times x plus h plus 4. So that is f of x plus h. What I did was I plugged x plus h in for all the x's. Minus, so I just did this part right here was just f of x plus h. Now I'm going to do f of x. Notice I have the subtraction in between. So f of x is just 3x squared minus 2x plus 4. And because I'm substituting it in, I put it in parentheses. I should technically put this in parentheses as well, but the parentheses in the first term is just not as important. And then this is all divided by h. So this is technically the average rate of change, but we like to simplify this, make it a little bit easier to look at, combine like terms, multiply out some of this stuff, combine like terms, simplify, okay? So that's what the rest of this work is going to be all about. So let's start with just x plus h squared. So So I have 3. I still have this 3. Not letting go of that. The x plus h squared is going to be x squared plus 2xh plus h squared. And I've already multiplied out a binomial squared, and I just want to make sure that we all are aware of the shortcut here. If you have something that looks like a plus b quantity squared, it's always going to be a squared plus 2ab plus b squared. So that's how I'm able to do that so quickly. Now I'm going to distribute the negative 2 here, plus 4. I'm going to distribute the negative to every term here. This is something that people usually forget. So it's going to be minus 3x squared plus 2x minus 4. And this is still all over h. So now the last step here in multiplying this out is to distribute this 3. So I'm going to have 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 4 minus 3x squared plus 2x minus 4 all over h. And if you can get to this point and you can do it accurately, the rest of this is actually a lot of fun, because you'll notice that we have a lot of the same terms, just opposite sign. So I have a 3x squared and a negative 3x squared, which if I add them together, I get 0. I have a negative 2x and a 2x, which if I add them together, I get 0. And I have a 4 minus 4, which gives me 0. And so now I'm left with 6xh plus 3h squared minus 2h all over h. Now, since every term in the numerator has an h in it, and there's an h in the denominator, I can say h divided by h is 1, h divided by h is, or h squared divided by h is h, and then this h divided by h is 1. Now, if there was just an h here and not a 2h, I would still leave a 1 for this term. Don't let this term disappear. So this gives me 6x plus 3h minus 2. And this is actually my final answer. And you might be wondering, why are we doing this? Why would you make us do something like this? Okay, I don't come up with the curriculum, first of all. Second of all, you're going to have to do this in calculus. So if you're taking pre-calculus so that you're ready for calculus, this is going to happen for you. And third, now we can find, so this is a quadratic. This is some quadratic. I don't know exactly what it looks like, but it's a quadratic. It might look something like this, okay? So let's say it looks something like this. And I wanted to know the average rate of change between any 2 points, okay? So as long as I know the starting point, let's say negative 4, and the distance of the interval, so the distance from here, the distance from the starting point to the other point. So these are my 2 points. So the distance from here to here is h. So let's just say that is 3, okay? So let's say x is 4 and h is 3. I can plug that in. So if I plug that in, I get 6 times negative 4 plus 3 times 3 minus 2. So that's negative 24 plus 9. That gives me negative 13. Nope, negative 15 minus 2, negative 17. Okay, so my drawing is terrible because my drawing has a positive slope, and this is clearly a negative slope. But it's saying that the average rate of change between those 2 points is negative 17. And I can do this for any starting point and any interval for the entire function, and it will give me the average rate of change over that interval. And this becomes really important idea when you get to calculus. All right. I'm going to go through these next few slides pretty quickly. You can read these on your own, but it should make sense anyway. A function is increasing if as x gets bigger, so does y. A function is decreasing if as x gets bigger, y gets smaller. And a function's constant if as x gets bigger, y stays the same. You have a relative minimum if you have an open interval where the value, you have a smallest value in that interval. So it can look like this, it could look like this, it could look like this. These are all relative minima. You have a relative maximum if you have some largest value in an open interval. It could look like this, could look like this. Okay, these are all examples of relative maxima. Even in odd functions, we will take that into the next video. So I will see you in the next one.